Hello, everyone. It's good to see people in person. I've done virtual meetups, talks, videos for a long time, but this is the first in-person thing I've done, so go easy on me. But I'm here to talk about opt-in design, which is a blanket term I'm using for this new age of web development tools and frameworks that we're seeing emerge in the recent years. So first off, to clarify the word design, this is not a UI design talk, although graphic design is my passion, clearly. It is also not a systems design talk. We're not here to talk about design systems or anything of that nature. We're here to talk about API design, so the way that you structure your code and you author it for other people to use. And we're going to try to learn what good defaults really mean when you're trying to build something, when you want to start small and configure your way up into something more complex. And also finding and building the best tools, frameworks, et cetera, for everyone, you, your team, anyone that you're working with. So hoping you can walk away with some tools to like author better code and also find frameworks that match what you're trying to do a little bit better. So first off, I'm Ben. That's my face, but bigger. I am a core maintainer at Astro. That's our actual URL, astro.build. I call myself the CEO of whiteboards. WTW.dev is where I host all my videos, a little preview link here, but I do a lot of content about React, MDX, Astro, et cetera, all 1-minute snippets about these topics. At least got to plug it a little bit, right? And my values, I at least like to put them here. Be caring, be clear, be casual, because technology is a scary thing, so explaining things in a clear way and being a little bit informal and jokey about it is my mentality. So I'm hopeful. So we'll go to the next one. Looks like as I click the link. There we go. OK, so first off, React developers in the room, raise your hand. People who use it, beginner immediately. I can't believe it. It's use React. OK, keep your hands raised. Keep them raised. So keep them raised if you've written code that has done something like this before with use effects. OK, more hands went up. I didn't even ask for that. Also keep them up if you've Googled something like this before. OK, so everyone's hands are still raised. If you haven't looked around, no surprise there. And that's because, and you can put them down. You can put them down. That's it. But that's because of sort of a principle that's core to how React is designed, which is that you re-render everything by default. That's an assumption that they make because they want you to develop applications, things that are interactive. And the ethos of that it starts off easy and then gradually gets more hard and complex as you go. So one nicety that React has is, of course, you can recalculate anything that you want because everything is going to rerun as you go. Here I have a shopping cart example you might have on an e-commerce site. Very, simplified code example. But say you have like the quantity of what someone is purchasing and you want that to increment and decrement. And you want to calculate the price based on the quantity that they have in their cart. Well, since React is going to rerun the entire component that state is encapsulated inside of, you can say, all right, anytime this state variable changes, it's going to rerun the whole shopping cart function and rerun this calculated price here. And calculated price is like utility function. So when you update with that text input, it'll change this state, which triggers a whole function to rerun. So calculated price will also come back with the new value to display in the UI. So all pretty simple, right? Where if you just want to calculate one based on another, you just write a new variable and you run your function. But of course, what if quantity is coming from somewhere higher up? Anyone in here might have worked with like Redux or GraphQL or something else that has more hoisted state. If you're dealing with that, then maybe you have a provider that is providing all of that state that you're rendering on the page, passing it down as a prop, which of course means that if the quantity ever changes somewhere down in the UI, it's going to rerun everything in this box. So if this wraps around the cart flyout that is flying out from the side, it's wrapping around your navigation bar, anything is subject to re-rendering. And if you hoisted that state a little higher, you put it in the entire cart provider, the whole checkout flow re-renders when you change your quantity. Or you put it in your classic provider, which is what you end up with global state, where you could have your entire app re-render unexpectedly if you're trying to change something. Specifically with React context is what we're talking about there. And at that point, it's time to break out the use memo hammer, the thing that we were Googling earlier, because you're conscious about performance now. You understand these pitfalls. You read the blog post. So now you decide, OK, Kent C. Dodds told me to wrap it in use memo. So I'll go ahead and do that, list quantity as a dependency to make sure that expensive calculate price function only runs when the quantity is changing. It's not rerunning when other unrelated stuff happens. But of course, you have to be conscious of what you're doing there. And this is what I would call opt-out design, where the React developers assumed a goal. They assume you're trying to re-render everything. You want it to be interactive. And this lowers developer friction as much as possible. You can just write variables, and you know they're going to update. And this hides complexity from you so that you can ship the app pretty quickly, and you know everything's going to be interactive as you expect. But that means you're dealing with the complexity monster later when you learn about how all of this stuff works. So now I'm going to attempt to whiteboard that. This is the most experimental part of the talk. We'll see how it goes. But hopefully, can y'all see the word hello in the back? I'm getting thumbs up. I'm surprised. But yeah, I can at least try to draw out sort of what I'm trying to communicate here, where usually, you know, this can be your starting point. Let me erase the word hello now that we have that. But say you start your application journey here. And you are slowly, you know, working with your team, you're developing features, and you get all the way down here. So the start of it is, you know, hello world. So I guess I'm writing the word hello again. But this is hello, and this is, you know, when you actually ship your application. And there's a lot of things that happen along the way, of course, where you're making decisions, you're progressively adding complexity to the flow as you go, but the friction is going to be really, really light. I guess I'll just stick with a black marker here. But you slowly go down, and then eventually you discover all the complexity that you have, and you know you deal with the fire of everything going on. My goal was to draw the little, like, you know the dog? He's kind of like this. He's saying, you know, this is fine. That you deal with that towards the end of your journey. And that's because you're offsetting the flames or the friction that you're dealing with until it's a little bit too late. You deal with the user metrics, and you need to sort of correct the code that you had. So the sort of spectrum that you have there is, you know, DX is number one. This is your number one priority that you're dealing with. And then when you get down to the bottom, now you've realized that user experience number one. So you go back, opt out of things, and update your performance. So the goal of APIs and the things that you use, in my opinion, should be to sort of flip this spectrum in the other direction, where to start, you're actually trying to be focused on user experience first. So that is your number one priority that you're trying to address. And then when you're going up here, you probably don't want to confront the everything is fine dog right away. That's a lot of complexity to deal with. So the goal of the tool should be start from a baseline and have, you know, little sparks of complexity as you go. I'm trying to draw like little, you know, sparks of friction that you might deal with, so that you deal with friction, but you're distributing out everything as you go, slowly opting in with more complexity points, and then getting to number one developer experience without losing the user experience side of things. So you can get to the other side of the chasm without, you know, a big blow up anywhere in the performance metrics, getting both user and developer experience in tow. That is what I'm going to talk about here with opt-in design. I hope that session went well. Did everyone see it? Can we get thumbs ups if that made sense? Yeah, OK. And we're getting claps too? I love y'all. OK. So we're talking about here, how can we do this differently? And there's many, many approaches that people have been experimenting with. SolidJS is the one that's interesting to me. This is quoting Fireship, a popular YouTuber that explains things in 100 seconds. It's a declarative JavaScript framework building fast UIs with control over what you're making reactive in your code. I call him the second best YouTuber because I'm on the platform. So this is a React and a Solid component side by side. You'll notice that they're roughly the same amount of lines, and everything is set up in a similar way. Where at the top here, we're importing a utility. It's called useState in React, create signal in Solid, although conceptually here, we can consider them the same thing. Oh, I have a clicker. And And when you're working with this for the first time, you might think you can kind of recalculate values the same way. In React, you would just write a variable. So in Solid, you might try to write a variable as well. And I have two actual clickable buttons here. In React, it's going to update the price as the quantity goes, assuming it's $3.99. And in Solid, the quantity updates, but the price isn't. What's going on there? That's because in Solid, you actually have to declare what is computed from other properties. You might have heard of the word compute if you've used Vue.js maybe. But in Solid, they use a slightly different principle. There we go. Where you can actually create a function that is going to rerun every time the price changes. And Solid has a little compiler around JSX in order to treat this correctly. So a function is assigned to Solid. This is a thing that you might need to rerun based on dependencies. And the dependencies are based on actually the sort of chain of reaction that goes on here, where in our text input, this is the source of state variables changing, where when the on input fires, it's going to update quantity, which can then update anything that depends on quantity. But in React, it doesn't really understand dependencies at all. It's just going to blindly rerun the whole function because state was declared here. But in Solid, it's actually granular down to the thing that's being rendered. So it's really smart in saying the input is the part that renders on the page, and quantity is the part that updated. So the only thing I'm going to re-render is the price, which I hopefully highlighted in one of those. I didn't. But because it was able to figure out price is being rendered on the page, it's only going to rerun where the state is used. So price is used, it'll re-render this part of the DOM. It will not rerun the whole function. While React is doing it based on where state is declared. So it reruns the entire thing a little bit more wastefully. And this is part of a whole wave in how frameworks are thinking about things in an opt-in manner. Svelte is one of them, using a $ to opt in interactivity. This is a more interesting example because they use very spicy syntax. But in here, variables are just variables that you can reassign. And they use a $ to say that this variable depends on some other. And it's able to compile away that quantity is a dependency, so it'll recompute this when this changes. And it'll only rerun the part of the UI that depends on it, which is the price component. So this takes me to some core principles that I have around opt-in design, or at least reverse engineering what that means. And there's three components. First one being find the lowest common denominator in what you're trying to build. The second being make complexity easy to add, but only when intended. Don't make it like an accidental foot gun. And stay user first when you're deciding that default. It's not meant to be developer first. The real way to be developer first is long-term developer experience, not necessarily the hello world short-term. So digging into each of those, when you're trying to find the LCD, as I abbreviate it later, you're trying to find the simplest use case for the tool that you're building. And in React's example, the simplest thing you could build is just like a static blog or something like that. It's just HTML. There's no interactivity to speak of, let alone re-rendering. So when you're designing an API like SolidJS, they thought, all right, let's not re-render by default and have an opt-in switch, which is a function or a $ in Svelte, in order to opt in to that more expensive behavior. But it also has to make sense with what you're coming up with. You don't want like a car with opt-in wheels. I mean, the car's always going to have wheels, so you might as well add that as a baseline for the hello world. Developers shouldn't have to do all the work. But you should have just enough where they can add complexity easy. And that takes us to our next one. You want to make it easy to add that complexity. Just add that $, and then everything works as expected. So $'s the example I have there. We'll also talk about Astro in a moment and how it can opt into shipping JS in a very nice way. And this is the opposite of what I would treat other frameworks like React, Next.js, approaches like that, where you start with a kitchen sink of 120 kilobytes of JS, and you slowly code split your way backward when you get the Lighthouse scores back. The goal is to have that Lighthouse score of 100 for that hello world and slowly add things onto it. And every time you add a little complexity, a little JavaScript, check those metrics again and see if you're making the right choice. The point is actually having choice in there. And the third one is staying user first with that default. So a low complexity baseline usually means better user experience just because of performance a lot of the time, sometimes with security vulnerabilities as well. And one example of that, of course, is when you opt in to re-rendering parts of the UI, you got fewer CPU cycles, any number of work that your computer is doing, so low-powered devices, poor internet connections, you'll get better performance down the wire. So if you start with less complexity, you probably will just get there, but at least keep the user in mind. And there's a whole world of examples around it. Just checking the time there. So Deno is an interesting one that I just started playing with, or Deno, as I've learned it's called now. It brings opt-in to permissions in whatever you're building. If you've ever used Node.js, you know that you can just kind of call file system APIs and wreak havoc on a machine if you want to. And Deno, which is from the creator of Node, that's literally Node backwards, or it's not Node backwards, it's like a anagram, is that the word? Yes, thank you. But it is from the creator of that, trying to do a fresh start around what JavaScript on the server could be. And one idea there is making all of the features opt-in. So anything that could be a problem, like accessing your internet, being able to read off of your file system, being able to access your environment variables. Like how many times have you doxed yourself trying to get process.env and then it spits out just everything on your computer? Deno wants to lock all of that down, Deno. And each of these are like the principles we talked about earlier: lowest common denominator, complexity, user first. And I feel like it addresses all of those pretty well. The lowest denominator is someone just trying to build a CLI tool with Deno. They don't need any I/O or network access, so it's good to just shut off their access to that. And it is definitely additive. You start with no flags, add them on, and it's very clear what those flags are doing, so you can't be unintentional about it. And it is user first. We're talking about security here, so the default is going to be the most secure option. The next one is, of course, Astro. Hey, bringing opt-in to shipping client-side JavaScript on your sites. So this is actually an Astro component, which is another templating language. Yes, another one. But it is just like JSX in a way. The only difference here is we got these little dashes instead of using a function wrapper. But in this example, we have just some static HTML that's rendered here. No JavaScript is shipped to the client to render this HTML. It's just markup, rendered server-side or during a static build, either one. And then if you want to add interactivity, you're free to import any component framework you want: Vue, React, Svelte, etc. And you can import it in line and intentionally add a little flag here to say, this ships client-side JS, and I only want that JS to load when the component's visible on the page. So when you scroll down to that component, I want to load React and the like button that we're trying to get. So when they go to our home page, it's 0.js and it loads instantly. You get 100 on Lighthouse. And then when you scroll down to the heavy image carousel, that is when it triggers everything. So you're really intentional with everything that you're adding. And of course, the lowest denominator there is you're building that home page with no JavaScript, and we're trying to make sure that's as performant as possible. And it is additive with what we're trying to do. It's a client directive. It's clear what it's trying to do. And you even have flexibility of when the JavaScript ships. Here I'm saying when it's visible. And it is user first. Core web vitals matter. Low-powered devices are important. So offloading all that work to the server, if we can, is definitely a win. So the last example is a really new one, actually. I've been playing with React server components. I don't know if anyone else has been playing with that. Next 13, a few nods out there. But it's an interesting pattern where they're actually bringing opt-in to data loading or adding loading spinners to whatever you're trying to send to your user. So this example is a component that runs on the server. And if description needs to do like an async fetch to your CMS to get whatever product description you're trying to display, it will block sending anything to your browser until that CMS data is done loading server side. And then for this bit of information, our review section, we decided this is less impact. We don't care if we ship the whole page to the user without the review section loaded. So let's make sure we get that description to them as fast as possible. And we'll put the review section behind a loading spinner. And all that logic will still run on the server, and it'll stream down the update when it's ready with a nice little skeleton as a fallback. You might have seen, like, you know, it's kind of a placeholder where it has some like gradient boxes that kind of look like a review until it's loaded. That's the kind of experience they had in mind building it. And it's definitely a nice lowest common denominator. Your critical pages can be blocking for like all the async requests, no loading spinners here. We're going to get it to the user with good lighthouse scores because everything displays all at once. And it's additive, where the least complex option is block and load, but the more complex option is dealing with fallbacks. And that's something that is behind the suspense boundary, as it's called here. And it is, of course, user first for similar reasons. We're minimizing the loading in all of the client-side JS that we're shipping to your browser. And we're also being conscious of layout shift. Whenever you have loading spinners, things can shift around while that data is loading in, because you don't know how big it's going to be. The loading spinner has to be roughly the size of our review box. So we're trying to avoid that experience where possible so that Google's able to crawl your page a bit better, and so you don't get a bunch of thrash when you're actually loading it on your site. So thumbs up. Do I have time for a demo, or are we at time? OK, there we go. So I have a demo app here on astro.new. If anyone has a computer out, go to astro.new right now. You can try out Astro yourself. I see some people looking down. That's good. Done my job. But we have templates for all sorts of things, a basic site, a blog, doc site, etc. And I'm just going to play with a few of the features there. I have a ready-made one where I've already npm installed, of course. But it'll take you to an online editor. This is StackBlitz, which is a really nice way to just try something without cloning it yourself. And this is a basic Astro app, or an Astro site, I should say. So it has one page, and you can see it's file-based routing, similar to Next.js. It's literally pages. And this is our index route, which is just displaying some server-side, or in this case, a static build of JavaScript in our page, or lack of JavaScript, I should say. And if we go to our network activity, it might give us a whole ton of stuff from StackBlitz, but we can see it's just going to send down these scripts here, but it's not going to send any like JSX. There's no React and React DOM. There's no virtual DOM because there's literally nothing re-rendering on the client at all. This is just a regular server-side template like you may have dealt with, like Liquid, Mustache, all of those languages, but modern, because this allows you to use components exactly as you would in JSX. So it's the same sort of principle there. And we can see we're importing a layout, which is just like any other component. And we're displaying some server-rendered HTML. So of course, we want to look at, this is a React meetup. How do I use React in this thing? I'm not going to use it if I can't. So to demo that, I can actually add React to this, literally by calling Astro add in my terminal. So you can add any known integration or deployment adapter with this CLI. Here I'm going to run add React and also Node, maybe play with some SSR. And when you do that, it'll install packages if they aren't already installed. I already have them. And it'll update your config file for you. So when we talked about that opt-in thing, it better be easy. Otherwise, there's too much friction for me to use the tool. It's not enough payoff. So we made it very low friction. It'll just update your config, import everything, make it a standalone Node server, all of the defaults that you might want, and it'll update your TypeScript config. Yes. Can we get a round of applause for not having to look up TypeScript docs? Yeah. No TypeScript. Yes. There we go. OK. And then when you hit yes, everything is updated. And now you are free to use React in your application. And I have a ready-made like button over here that I'll just paste in. And I kind of wrote this on the fly. I didn't run it, but I'm trusting my React knowledge here. So I have a like button. It's going to update the state, set liked, display that. A simple true-false variable. Probably played with that before. And then we'll go back to our home page and import it like any other component. So if I head over here, we can import our like button. And if you're using the VS Code extension, you'll get some nice autocomplete. StackBlitz is a little behind the times, so I'm going to manually import this guy. But we have our like button, and we can put it on the page like any other component. So we'll go ahead and do that. And now we see it here. And you'll notice it's not functional by default. And that's because we assume the default that you're trying to build for is 0.js. You're trying to server render an application to send to the user. And if you want to use client stuff, you have to be a little bit intentional of how you want to load that JS. So in here, I'm going to say, I'm going to load it just when the page loads, because it's above the fold, not really a big deal. But now this is going to opt in to shipping React and React DOM to the client. So it's really is that simple. You can use any framework that you want to. You can also hot swap this in your config if you wanted to change from using React to SolidJS like we talked about earlier. Install the Solid extension. If you want to install Preact, you might have heard of Preact, lower JS alternative to React, you can try that too. Because it's a very agnostic templating language, you can opt into any JS that you want to. But by default, you're just using server-side templating. And the last thing that I'll check out a little bit is server-side streaming, which is something I just realized we support. So I kind of wanted to play with it. So one thing that I'm going to add up here is maybe an async fetch for something. I'm not in Copilot mode, so I can't get a Pokemon API going really easily. So I'm just going to say lazy promise like that. lazypromise.astro. And this is our way to write scripts. You just write 3 dashes. You can call it front matter if you want to. You can also just call it a script tag. That's literally what it is. And inside of here, I'll do the classic await new promise. I write this a lot. Set timeout res. I think I did that right. This will wait 1 second before sending you HTML. That's what we're trying to do. So let me even write that out. Wait 1 second. And then we'll send it down. Resolved. I'll even make it 2 seconds just to make it a little bit more obvious. And no one's shouting, so I'm assuming I did the code right. But I'm trusting you. I'm trusting you. So I'll go ahead and import that from components as we did before. Lazy promise. And we can import it just like a React component. Everything is a component. And if I render that onto the page, we'll get some pretty interesting behavior, I think, where if we put that in, this should work. Does this render stuff to the page? Yes. Index. Interesting. I'm actually not seeing anything. Odd. OK. Maybe if I do that. All right. Stack blitzes. There we go. Interesting. OK. That's not the most compelling demo that I was hoping for. Dang. OK. Well, it was meant to stream in the like button, and then this will stream in 2 seconds later. So it'll literally update the page in real time, the same way you were looking at like the loading spinner before with React Suspense. We support that on both Node, Dino, Netlify functions, anywhere that you can deploy JavaScript. It's definitely part of the model. But when you're dealing with an online sandbox, things happen, especially with the dev server. So yeah, that is sort of the conclusion of my talk. Thank you, everyone. I hope you enjoyed. You can find me at bholmesdev anywhere. I'm on Twitter, TikTok, YouTube, Twitch now. This is my YouTube channel where I do whiteboarding videos like this. And also, I put together a little React Server Components and Dino demo, since it's really fascinating technology, and it's cool to play with it outside of Next.js to see what the future of React is. You can go there if you're at all curious, or just find the entire slideshow, also bholmesdev on GitHub, so you can look at it over there. But yeah, that's everything. I hope you all enjoyed. Thank you for your time.
All right.